Now, in the exercise 2.2, let us take the question number 10. See the question number 10. Write tan inverse of 3a square x minus x cube by a cube minus 3a x square, comma a greater than 0 minus a by root 3 less than or equal to x less than or equal to a by root 3 in the simplest form. Here, this is the given inverse trigonometric function. We have to write it in the simplest form. To write this inverse trigonometric function in the simplest form, we use the substitution technique. Means we have to substitute a trigonometric function so that we should get a trigonometric identity. So here we choose x is equal to a tan theta. This is a suitable trigonometric function to get a trigonometric identity. That is why we are taking x value like this. By implies theta is equal to tan inverse of x by a. From this equation we get theta value like this. Now let us take the given inverse trigonometric function. What is the given inverse trigonometric function? Tan inverse of 3a square x minus x cube whole divided by a cube minus 3a x square. This is the given inverse trigonometric function. In this inverse trigonometric function, we are substituting x is equal to a tan theta. So that is equal to tan inverse of 3a square. Here x is there, so we are writing a tan theta minus here x cube is there, so we are writing a tan theta whole cube whole divided by a cube minus 3a into here x square is there, so we are writing a tan theta whole square. Understood, my dear children, this step? By substituting x is equal to a tan theta, we are getting this step. Understood this step, my dear children? Right. That is equal to tan inverse of, in the numerator we get 3a cube tan theta minus a cube tan cube theta whole divided by, in the denominator you get a cube minus 3a cube tan square theta. Understood this step, my dear children? Right. That is equal to tan inverse of, by taking a cube common factor in the numerator from these two terms, we get here a cube of 3 tan theta minus tan cube theta. Understood this numerator part? Right. Now come to the denominator. Here also we take a cube common factor here. So we take it out. Then we get a cube of 1 minus 3 tan square theta. Understood this denominator part, my dear children? Right. Now that is equal to tan inverse of, by striking out a cube in the numerator and denominator we get 3 tan theta minus tan cube theta whole divided by 1 minus 3 tan square theta. These terms will be left after striking out a cube in the numerator and denominator. Okay, my dear children, if you observe this part, it is a formula for tan 3 theta, that is equal to tan inverse of, this part can be written as tan 3 theta because tan 3 theta is equal to 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. So because of this reason we are writing this step. Understood this step, my dear children? Right. That is equal to, it is in the form of tan inverse of tan theta. Tan inverse of tan theta means theta only, or tan inverse of tan x is equal to x only. What is x here? 3 theta. So we get this step 3 theta because tan inverse of tan x is equal to x. This is a property of inverse trigonometric function. So we get this step. Understood this step, my dear children? This is equal to 3 into theta means here tan inverse of x by a. At the beginning of the question we assumed, so we get this value. So this is the simplest form of the given inverse trigonometric function. Understood, my dear children? Right. Now come to the next question, that is question number 11. Find the value of tan inverse of 2 cos of 2 sin inverse 1 by 2. Now we have to find the value of this inverse trigonometric function. So let us take this given inverse trigonometric function, that is tan inverse of 2 cos of 2 sin inverse of 1 by 2. Okay, my dear children, that is equal to tan inverse of 2 cos of 2 sin inverse. Here 1 by 2 is written as sin pi by 6. Why? Since sin pi by 6 value is 1 by 2. So in the place of 1 by 2, we are writing sin pi by 6. Understood this step, my dear children? We wrote all the remaining part as it is. Just instead of 1 by 2, we are writing sin pi by 6. Okay, my dear children, that is equal to tan inverse of 2 cos of 2 into. Here, if you observe this part, it is in the form of sin inverse of sin theta. If sin inverse of sin theta is equal to theta only, this is the property of inverse trigonometric function. Therefore, we are writing here 2 into this value is pi by 6 because sin inverse of sin x is equal to x. By using this inverse trigonometric property, we are getting this value. Understood this step, my dear children? Right. That is equal to tan inverse of 2 cos of. By simplifying this part, we get pi by 3. Understood this step, my dear children? Right. That is equal to tan inverse of 2 into 1 by 2 because cos pi by 3, what is the value of cos pi by 3? 1 by 2. So we are substituting here the value of cos pi by 3. Then we get here tan inverse of, by simplifying this part, we get 1, 2 to cancel. Then we get 1. Understood this step, my dear children? Right. That is equal to tan inverse of, here again we are writing 1 as tan pi by 4 because tan pi by 4 is equal to 1. So we are writing here tan pi by 4 in the place of 1. Understood this step, my dear children? That is equal to tan inverse of tan theta. What do you get here? Theta only. By using the inverse trigonometric property, we get this value. Understood, my dear children? Right. Now come to the next question, that is question number 13. Not question number 12. This is question number 13. Find the value of tan 1 by 2 of sin inverse 2x by 1 plus x square plus cos inverse 1 minus y square by 1 plus y square, comma, modulus x is less than 1, y greater than 0 and xy less than 1. We have to find the value of this inverse trigonometric function. Okay, my dear children. Now let us take the given function. Tan 1 by 2 of sin inverse 2x by 1 plus x square plus cos inverse 1 minus y square by 1 plus y square. Right. That is equal to tan 1 by 2 of 2 tan inverse x plus 2 tan inverse y because 2 tan inverse x is equal to sin inverse of 2x by 1 plus x square. So instead of this first term, we can write 2 tan inverse x. Similarly, instead of the second term, what is the second term? Cos inverse of 1 minus y square by 1 plus y square. Instead of this term, we can write 2 tan inverse y. That is why we are writing these two terms. Understood this step, my dear children? Right. That is equal to tan, just multiply this 1 by 2 into two terms. 1 by 2 of, by taking 2 common factor, here we get 1 by 2 into tan inverse x plus tan inverse y. Now strike out these two, then we get tan of tan inverse x plus tan inverse y. Understood this step, my dear children? Right. That is equal to tan of, it is in the form of tan inverse x plus tan inverse y. There is a formula in the inverse trigonometric chapter. Tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. This is the formula. Okay, my dear children. Understood this step, my dear children? I wrote here that formula also. Tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. Right. That is equal to x plus y by 1 minus xy because tan inverse of tan theta is equal to theta. By using this inverse trigonometric property, we get this step x plus y by 1 minus xy. So this is the value of given function. Understood, my dear children? Right. Now come to the question number 12. Find the value of cot of tan inverse alpha plus cot inverse alpha. We have to find the value of this function. Okay, my dear children. Now let us take the given function. Now what is the given function? Cot of tan inverse alpha plus cot inverse alpha. That is equal to cot of pi by 2, because tan inverse x plus cot inverse x is equal to pi by 2. This is also property of inverse trigonometric functions. Understood, my dear children? That is equal to cot pi by 2. What is the value of cot pi by 2? 0. Therefore, the value of the given function is 0. Understood, my dear children? Right. Now, come to the question number 14. If sin inverse 1 by 5 plus cos inverse x is equal to 1, then find the value of x. Here, an equation is given. Now, we have to solve it. We have to find the value of x. Understood, my dear children? Right. Now let us write the given equation. What is the given equation? Sin inverse 1 by 5 plus cos inverse x is equal to 1. This is the given equation. Now if you send this sign into the RHS, it becomes sin inverse. So sin inverse 1 by 5 plus cos inverse x is equal to sin inverse 1, because sin theta is equal to x by implies theta is equal to sin inverse x. By using this result, I wrote this step. Understood this step, my dear children? Right. This implies sin inverse 1 by 5 plus cos inverse x is equal to, what is sin inverse 1 value? Pi by 2. Because sin inverse 1 is equal to pi by 2. That is why I wrote here pi by 2 in RHS. Understood this step, my dear children? Right. This implies cos inverse x is equal to pi by 2. We are sending this term to RHS. Then we get pi by 2 minus sin inverse 1 by 5. This implies cos inverse x is equal to cos inverse 1 by 5, because sin inverse x plus cos inverse x is equal to pi by 2. This is also property of inverse trigonometric functions. Understood this step, my dear children? Right.